Hello everyone, Aaron here. Welcome back to Leetcode, and let's dive on in and see what we're up to today. Oh no, it's another tree problem. Kth smallest element in a binary search tree. Right, well, we've done a lot of tree problems in TypeScript. Do I want to do this one? Yeah, let's do this one, but let's not do it in TypeScript. Let's change things up a little bit. What do we got? C, well, I know Python, but it's kind of the same. JavaScript, basically the same. Oh gosh, Scala I've not used in a long time. Racket I've never used, but would be interested to try. Could go for C. Yeah, let's do it in C. Let's do it in C. Okay, we've got a struct for a binary tree node, and we're given that as a pointer, and we're asked for the kth smallest value, 1 indexed. Okay. Given the root of a binary search tree and an integer k, return the kth smallest value, 1 indexed, of all the values of the nodes in the tree. Okay, well, the naive solution would be just to do an in-order traversal. We've seen that a few times already. Should we give that a go? I mean, it can't hurt, can it? Right. Kth smallest struct tree node root int k. Right. Let's jump on in. I think we're going to need a little help over here. Let's go with int kth smallest helper struct tree node root int. Actually, could k be used as our counter? I don't know. Possibly. Let's get back to it. If that might be an optimization we can do in future, and then we won't even need this helper function. But for now, what I'm going to do is I'm going to pass through the current pointer just so I know where exactly I am in my traversal. If current is equal to k, return root.val. What's the case where the value doesn't exist? Oh, the value is defined to exist, so we're okay. We don't have to. If the root is null, then this is never going to be true. But we will handle that case because we need to for our recursion anyway. If the root is null, then... Oh, actually, this is a little bit of a problem. How do I signal failure? Always a problem in C. How do you signal failure? So the node value is always positive. So what I can do is just use a -1 to signal that I've failed. Something a bit nicer, like passing through a signal flag or something as a pointer might be slightly nicer here. But because we know the node value is always positive, then we can just use the -1 value as a flag saying, whoops, something has gone wrong. Oops. So, actually, now I'm even looking at current and thinking, ooh, that may not be what we want to do either. Because k might be the one we want to go for. If we set k to be 1, and we go this, if we're looking for 1 this way here, we get back a -1. Somehow we need k to keep track of what on earth has been happening here. What we need to do, so I think I need to actually change the way I'm approaching this. we're doing an in-order traversal. The trick is just keeping track of where we are in that in-order traversal. Every time we check a value, we want to decrement k, basically, because that is the count of where we are. 1, 2, 3, 4, 5. Yeah. So, or the alternative way of looking at it is current gets incremented every time. So there's two ways of looking at this. One is that k can be reduced by 1 every time we check a value here, or the current can be incremented every time we check a value in our tree. Rather than passing around a new parameter, why don't we play with k and see what happens? And what I'm going to do is I'm actually going to make k a pointer. So now it's if k equals, actually here our recursion wants to be a little different. So if the root is null, return -1. We haven't done anything. Then we want to work down the left. And then what we want to do is here, if k is equal to in fact, no, if left does not equal -1, return left, because we found it. We found the smallest value. Otherwise, what we want to do is we want the value of k to be the value of k -1. Whoops, but we're in. Oof. Oh, I don't trust my pointer knowledge to be fully up to date to do that shorthand. Let's do it the long way. K is equal to k minus, well, the value of k is equal to the value of k -1. If k is equal to 0, return root val, except that's a pointer. And then finally return return the kth smallest helper root right k. So the thinking is, if the tree's empty, we're buggered. Return a -1. If otherwise, what we want to do is we want to keep walking left. Just keep walking left. If we manage to find something that matched our kth smallest value in the left-hand side, then we want to give it back. Otherwise, what we're going to do is we're going to adjust our k counter, because we're now looking at the root value. If the thing we're looking at has brought us to the index that we're interested in, we want to return that value. Otherwise, we're going to need to walk right. That could also return a -1, but that's okay. It will just bubble that up through the tree. Let's set up the recursion here. We just need to kick things off. The result of kth smallest helper of the root and of the address of k. These are all things we want. So this kind of kicks things off. So let's have a go at this. Let's say we're given this tree. We've got 3 here. What we want to do, is it null? No, it's not null. Go down the left-hand side. All right, go back in here. Is it null? No, it's not null. Go down the left-hand side. Is it null? Yes, it is. So we return -1. Back up to here. Left is -1. So we go down here. K equals k -1. So it was 1, it's now 0. If it's 0, we return root.value. Great, we're done. Come back up here. Left is 1, so we return left. Up here, it works. Now we want to do the example of 3. We've got the 5. Got the and k is 3. So it's not null, not null, not null, not null. So we come up here, k is equal to k minus, so that was null, we got a -1 up, k minus 1 is now 2, it's not a 0, so we want to go down the right, that's a -1, bubble up. Now we're back here, the left said -1, so we want to decrement k, k is now 2, so 2 becomes 1, 1 is not 0, we want to go down the right, that's a null, we're going to return the -1. 3, we've got a -1, so we want to keep working down. K was 1, so we want to decrement k, it's now 0, return root value, which is 3, pass it up, this one here, the left wasn't that, okay. I think this kind of works, but I kind of want to do one more example where we're looking for the 4 maybe? No, let's look for the 2 in this one here, let's see what happens. So go down, we've got -1, the 2 becomes 1, that's not a 0, we go down the right, it's not null, so we go down the left is equal to, and it's going to give us a -1 back up, so we're going to take that off, we're going to get a 1, k is 1, gets decremented to 0, which means we hand back the 2, so that gets passed up there, which gets passed up there. Okay, I think this works. This seems promising. Let's give it a go. Don't know if this is the intended solution at all. Oh no! This didn't work at all. What's happened here? It output a -1. Why did it output a -1? We go root, we go k. If root is equal to null, it's not equal to null. In left. We go down here. I don't understand what's going on at all. Let's do some print debugging, shall we? So let's see what we're seeing at each given point. That's probably a puts anyway. So we're looking at the thing. Well, hang on. Let's run it, see what happens. What do we learn from this? It looks the 3, the 2, the null, the 2. Okay, so hang on. It's going through all of them. That's not what we want at all. I think k is going wrong here. Int target equals k. I think, oops, what's happened is the parameters are causing a problem. By passing down that parameter without sticking it in a variable first, we're probably causing difficulties. Let's see if that fixes the problem. No, it didn't fix the problem. It's going 3, 1, null. Well, let's see what... Oh. There's my typo. Oh my goodness. That's annoying. So, I had just a bare k here, and a bare k is the pointer value. I'm checking if the pointer is 0. It's a null pointer. I don't care if it's a null pointer. I care what the value is at that particular location. Oh, that's so annoying. The tiniest little thing. That worked fine. I'm curious if we can switch this back. I would hope the C compiler is smart enough that the parameter would automatically get stuck somewhere in memory. Looks like it did. Excellent. Let's add the other test case super fast. We want to do... Actually, just give me all of those. And we want the next line to be 3. Hopefully we get 3. We do. Great. Let's submit it. Whew. Hey, we were very memory efficient, but we were quite slow. We only beat 40% of the submissions, but we bet 90% of them on memory. So there's obviously some trade-off that I haven't made between the memory and the runtime. Not sure what that would be. There's probably some clever trick you can do with the null pointers inside the node tree and link them together in such a way that you can traverse it like a linked list. But that feels like a lot of work and isn't really worth doing. So I think what I'm going to do is I'm going to leave it there today. Thank you very much for watching, and I will see you all tomorrow. Bye. It's another tree problem.